Hi Year 12, it's Miss Hamill here. What we're going to be looking at in our presentation today is a new dot point, and this is based on current developments in packaging. This is quite a really interesting part of the topic, and it does look at a lot of new developments that are taking place in food technology. So this lecture will be divided into two parts. This is part one. So the dot point that we're focusing on is under the subtitle in the food manufacture syllabus. Okay, so this is for food manufacture. Now this dot point is looking at current developments in packaging, and the specific current developments that you need to be aware of, in addition to others, are active packaging, modified atmosphere packaging, which is also known as MAP packaging, and sous vide. There are other ones that we're going to cover in our lectures today and the next lecture, but you do need to be able to refer to these, because if you do get a question in the HSC, you might get a very specific question on one of these types of packaging. Now, an overview. The food packaging industry is constantly evolving, which means it's constantly changing. And it's a highly competitive part of the food industry because technological advancements are always allowing new forms of packaging to be developed and created. So because of technology, there are constantly new advancements and improvements in packaging, and these are there to meet our needs, which are also evolving and they're also changing. So people's needs are really based upon their lifestyle. So if people have a busy lifestyle, then they need food packaging that adds convenience. The other things are basically consumer concerns or consumer demands. Okay, so what the consumer wants. Things like biodegradable packaging is something that consumers are concerned about more and more. So when we look at what these consumer preferences are, they really can be summarized through the acronym SANIC. So sustainable packaging, packaging that's biodegradable and it's ecologically friendly, packaging that's aesthetically pleasing and it's a visually appealing design, packaging that's novel, which means it's new and it hasn't been seen before, so it's a little bit different or it's one of a kind. Packaging that's innovative, okay, so packaging that's unique, it's never been seen before, and it builds upon something that's existing. And finally, packaging that's convenient. So it is easy to use, it helps people save time, it helps people save energy, etc. So that is an overview of what consumers are interested in when it comes to food packaging. The first category of packaging that we need to look at is modified atmosphere packaging. So if you modify something, you change it, okay? Atmosphere refers to gas, and packaging is the container that food is held in. So modified atmosphere packaging is simply changing the gases or the air that surrounds food within a food package, okay? So if you think about a tray of chicken, when you go to the shops and you purchase a tray of chicken breast, you'll notice that those chicken breast pieces are side by side next to each other, and they're often in a plastic film and a plastic tray. And within this packaging, there is gas, okay? This is what makes up the atmosphere of the packaging. Now, modified atmosphere packaging is a type of packaging that changes the gas that is surrounding the food within a food package. Okay, so that's what it is, put simply. Let's have a look at what the definition is. So what is modified atmosphere packaging? It's simply defined as a method of packaging which extends the shelf life of fresh food products. And this is how it works. So this is also part of the definition. It works by substituting, so swapping in and out. Okay, so putting a different type of atmospheric gas inside the package with a protective gas mix. So this gas is considered protective because what it does is it keeps the food fresh. Okay, it keeps the shelf life long, or it extends the shelf life so that the food quality is intact. So the gas helps to keep the food fresh for as long as possible, and it retards or it stops the growth of microorganisms that might cause food spoilage. So using a MAP system requires an ideal mix of gases, okay? Because if we're subbing in gases, they need to be ideal. And when we talk about them being ideal, They are those which extend shelf life, and they are those which prevent spoilage by retarding the growth of microorganisms. So the ideal mixture of gases that are always used in modified atmosphere packaging are oxygen, nitrogen, and carbon dioxide. Now these are added to the inside of packages to ensure that when food reaches the consumer, it is in optimum or top-notch condition. Okay, so it does maintain that food quality. Now these gases are selected because they inhibit or they stop the growth of aerobic bacteria and microorganisms. Now just if we're flashing back to prelim, aerobic bacteria, what is that? Have a think. If you're thinking that those are the bacteria that require oxygen, then you're correct. So these are the bacteria and the microorganisms that require oxygen because they are aerobic. Now, if we do manage the environment of gases within a package, then these will not be able to operate. And therefore, if they are not working, it's going to extend shelf life. And it's going to keep that product nice and fresh. So the gases also help to control the environment or the gas environment around a food, because whenever food products like fruits and vegetables and meat deteriorate in quality, they do that because they are respiring, which means they are breathing. So as food products deteriorate, they let off gases. Now, having a modified atmosphere packaging and having a gas mixer around a food, like a fruit or veg or a meat, actually helps to stabilize the gases even as it is respiring. And this is what helps to extend that shelf life. Now, for modified atmosphere packaging to be effective, the packaging material must allow the gases to pass through and escape from the package once it's sealed. Because if those gases can't escape and they do remain, then the food product is going to spoil. Now, there is a good video, and I will put this video on Google Classroom, and there will be some questions that you have to answer about the video. So at the end of this lecture, I'm going to ask you to log on to the classroom and watch it. Now, I've created this graphic organizer to help explain the different types of modified atmosphere packaging, because we need to remember that it is an umbrella term. Okay? There are lots of different subcategories of modified atmosphere packaging. Now, the 4 types are shown through the mind map. So we've got the active packaging, gas packaging, vacuum packaging, and barrier-specific packaging, which are all examples of modified atmosphere packaging. So the first category that we're going to look at is barrier-specific packaging. Now, this packaging allows some gases into the packaging at different rates and excludes others. So the respiration or the breathing of fruits and vegetables produces moisture. And if this moisture remains in the packaging, it can cause changes to the inside of the food packages. Now, specific materials are used for specific food items for barrier-specific packaging. The packaging must be transparent, which means you can see through it, and it has to have anti-fogging properties. And this prevents that condensation from building up inside the packaging. Because when moisture is within a package, it will turn into water or condensation, those little droplets of water, inside the packaging if they are not able to escape. Now, a really good example of a food product that has barrier-specific packaging is shown below. So pre-cut fruits and vegetables, such as salad mixes, have barrier-specific packaging. So if you go to the shops, if you go to Woolworths or Coles and you pick up a bag of salad greens that are pre-washed, pre-cut and mixed in a bag, you'll notice that that bag is filled with gas, okay? What that does is it helps to balance the gases within the food product and within the package so that it doesn't cause those salad leaves to spoil. But the plastic flexible packaging that surrounds the salad leaf, so the bag that it is contained in, does allow gases to escape, okay? And it prevents the buildup, which means that the vegetables or the salad leaves can respire without spoiling. Now, we can see here that pre-cut fruit and pre-packaged salads are 2 clear examples of barrier-specific packaging. The next category that we're going to look at is vacuum packaging. Now, Vacuum packaging is something we've already spoken about in class. It is technically known as cryovacuum. Now, it does involve removing the air from the inside of packages to create a vacuum, so that the packaging seals the food product and eliminates any air from being inside of it. Now, it is a very cost-effective method of packaging foods, and it's often used domestically. There are lots and lots of different foods that are packaged using vacuum packaging, and these include cheeses, salami, bacon, ham, fresh noodles like Hokkien noodles, coffee, olives, and sun-dried tomatoes. So these are all the examples that I've just explained, and you'll see that this is a cryovac machine and there is no air or gas surrounding the food. Okay, the noodles are seen through here, and then the sun-dried tomatoes. The third type is gas packaging. Now, gases that are within or inside the packaging are specifically designed to maximize the shelf life, which means to extend the shelf life to make it as fresh as possible for as long as possible. And they're also there to meet the requirements of the food product within the package. So different foods will require different gases. So if we think about chicken, that would require different gas around it compared to maybe beef. Now, manufacturers replace the air, which is also known technically as the headspace within the package, with gases before the package is sealed. Okay, so it is simply gas flushed. Okay, so this gas flushing is what adds those gases inside the packaging. Now, the packaging material must also not be permeable or porous so that the correct gas balance is maintained. So this method is used for foods such as fresh pasta and snack foods like chips, pretzels, and popcorn. So when the products like chips are packaged, nitrogen specifically is used to replace oxygen. We know that chips are very high in fat, and if fat combines with oxygen, it does cause rancidity, which is the spoilage of fats. So by replacing the gas oxygen with nitrogen, the bag can stay inflated, and it also extends the shelf life of the chips. Now we can see a really clear example here. When you buy a packet of chips, it always is gas flushed. So this gas flushing process adds the nitrogen, and this prevents rancidity and extends shelf life. Now, other foods that I've mentioned that do contain this gas flushing or gas packaging method are things like fresh pasta. So if you look at the inside, if you ever pick up a packet of fresh pasta, there is gas that is contained within the packaging. The next category is active packaging. Now, this is a really interesting one. So you've probably seen these little guys inside your food products before, and you'll notice it says don't eat. It also says often that it is absorbent. Okay, so this is known as a scavenger sachet. Now, these are placed inside our food products to absorb gases produced by foods during storage, because we know that our foods are constantly respiring, which means they are constantly breathing and they let off gas. Now, these gases cause food deterioration. So active packaging is a system that is used to modify the environment in the package as the product changes during storage. Now, active packaging films are used to hold food and provide a barrier against outside influences. And small reactive packages, known as scavenger sachets, so these guys over here, these are placed inside packages to control the internal environment of them. Have a think where you've seen these scavenger sachets before. They're commonly seen in foods like naan bread, tortillas, or nori sheets. So this is one example. So in this example, we can see we've done scavenger sachets. The second example is looking at sachets or pads of absorbent material. So these are commonly seen with fresh meat and poultry. And what they do is that they absorb excess moisture that might escape during storage. Now, by having these pads that are absorbent, it does help to maintain the appearance and the sensory properties of food when pulled. And I'll just show you quickly, not the one on the right, this one on the left. That's a scavenger sachet that has been placed inside a tortilla package. Now, as this bread ages and deteriorates, it lets off gas. These gases are absorbed by the scavenger sachet, and therefore you'll notice there's no mold that has been built up on the outside of the tortilla. On the opposite side, we can see here this food package, and it has been infected with a lot of mold. So there is evidence of food spoilage here. Now, the reason why there's food spoilage on this particular product is that there is no scavenger sachet, which means the gases that are surrounding the food are adding to the aerobic bacteria and the other microorganisms that are creating an environment where microorganisms can grow and cause food deterioration. So the scavenger sachets are a really key feature of active packaging. Now we're going to have a look back on the previous slide now, and I'm just going to show you another example of active packaging on display. So if we look carefully here at this image, you'll see these pads of absorbent material. These absorb moisture, and they're often seen, you can't really see that word, it says moisture. These are often seen in products that do let off gases and do let off liquid. And by absorbing them, it does promote the sensory characteristics of the product so that they are pleasing to the eye and they do maintain their quality. All right, there's a few review questions that I'd like you to complete. Now, I'm going to ask you to submit these review questions using Google Docs. So have a go at completing that activity. There's also a Google form that's linked to this lecture, so I'd like you to also complete that. That is the final slide for the lecture today. So if you have any questions, please don't hesitate to email me or ask me a question on the Google Classroom. Thank you.